Welcome back to The Explainer. So today, we're diving straight into the fundamental engine that's literally driving the AI systems you and I use every single day, machine learning. Now, we hear this buzzword constantly, right? In headlines, boardrooms, everywhere. But today, we're actually going to go beyond the hype and look at the real mechanics of how machines learn. We'll be using some pretty relatable analogies to give you a rock-solid understanding of what is actually happening under the hood.
Okay, let's dive into this. Think about how we teach a child to recognize a dog. We don't sit them down with a strict checklist of rules, right? We don't say, okay, a dog must have exactly 4 legs, a tail of X length, and emit a bark at this specific decibel. That's just way too rigid. Instead, what do? We just show them hundreds of pictures. And after seeing enough examples of different breeds and sizes, they just kind of get it. Their brain extracts the pattern. Well, machine learning works the exact same way. Instead of programming every strict mathematical rule into the software, we basically just let the computer extract the patterns directly from massive amounts of data.
All right, to keep things super easy to follow, here's our visual roadmap for today. First, what is machine learning? Second, how machine learning works. Third, the 3 main types. Fourth, machine learning in everyday life. And finally, AI versus machine learning.
Okay, jumping right into section 1, what is machine learning? Let's get the basics down. Have you ever wondered how this actually works compared to the old way? Because for decades, software relied entirely on traditional programming. Basically, a human developer had to sit down and literally write out every single fixed instruction. If X happens, do Y. And hey, that works great for simple stuff, like calculating your taxes. But traditional programming completely breaks down when tasks get incredibly complex. Imagine trying to translate the subtle nuances of human languages, or navigating a car through a chaotic city street. You literally cannot anticipate and write a rule for every single scenario. So machine learning flips the script. Instead of relying on a human to write the rules, the computer just studies millions of examples and figures out the underlying patterns entirely on its own.
And this brilliantly illustrates the difference. Let's say you want a computer to identify apples in a photo. Under the old rules, you try to code it, saying something like, apples are roughly round, they're red or green, and they have a stem. But wait, what if the apple is yellow? Or what if it's bruised? Or actually, what if a toddler took a massive bite out of it? The code immediately breaks. With machine learning, you just bypass all those rigid rules entirely. You feed the system thousands of pictures of apples in every state imaginable. It studies the pixels, mathematically learns the abstract concept of appleness, and boom, it can instantly identify new ones, stems or no stems.
Moving on to section 2, how machine learning works, a step-by-step process. So the actual technical process generally follows 5 distinct steps. Let's use email spam detection as an example to make this super concrete. Step 1 is collect. We gather thousands of historical emails. Step 2 is clean. We organize and format the data so the machine can actually read it. And fun fact here, data scientists actually spend about 80% of their entire time just on this cleaning step. It is tedious, but absolutely crucial. Okay, step 3, train. We feed the system emails that are already labeled as spam or inbox, which allows it to relentlessly crunch the data and learn the patterns of suspicious keywords. Step 4 is test. We check its accuracy against an entirely new batch of emails it hasn't seen yet, just to make sure it isn't just memorizing the data. And finally, step 5, predict. When a new email arrives tomorrow, the deployed model instantly predicts if it's spam and seamlessly protects your inbox.
All right, section 3, the 3 main types of machine learning.
Now, what's really interesting here is that there isn't just one way machines learn. Our first type is supervised learning, and this is by far the most widely used approach in the industry right now. In this method, the computer learns using data that already has the correct answers securely attached to it. It's kind of like a teacher checking a student's homework. The teacher firmly holds the answer key, and the student learns by repeatedly doing the work and comparing their answers to those known correct answers.
To see this in action, just look at how modern real estate apps predict house prices. You feed the system vast amounts of historical data, using variables like the number of bedrooms, the square footage, the zip code, alongside the final selling price. Because those correct selling prices act as the answer key, the model meticulously maps out the complex mathematical relationship between a house's features and its market value. So once it's trained, it can instantly evaluate a brand new listing. And this exact same supervised method is the engine behind instant bank loan approvals, and it's even driving huge breakthroughs in medical disease diagnosis.
But well, what if you don't have an answer key?
That brings us to unsupervised learning. Here, the raw data has absolutely no labels. Imagine walking into a massive room full of strangers without name tags. Without knowing a single thing about anyone, your brain naturally starts grouping them, maybe by rough age group, style of dress, or who is talking to whom. You are automatically finding hidden structures and patterns without any prior labels, and that is exactly what the computer algorithm does with massive data sets. This remarkable ability to cluster data without labels is just incredibly powerful, especially for businesses seeking an edge. It's exactly what drives modern customer segmentation. When a massive online retailer analyzes millions of global shoppers, it groups them into invisible, highly specific profiles based on really subtle buying habits. And that is exactly how it generates those hyper-accurate, almost psychic product recommendations on your homepage. It's also a vital, proactive tool for flagging anomalies, like identifying highly unusual behavior hidden within billions of real-time credit card transactions.
Can you guess what happens next? What if a computer needs to make a continuous series of decisions in a highly dynamic, ever-changing environment? Well, that requires reinforcement learning. This is entirely inspired by how humans and animals learn through constant trial and error. Think about it. If you teach a dog to sit, you reward it with a treat for doing it right and give it nothing if it fails, so it tries again. The machine operates on the exact same fundamental principle. It receives mathematical rewards for optimal decisions and penalties for bad ones, rapidly improving its logic over millions and millions of automated attempts.
Because it relies on maximizing those rewards through endless high-speed trial and error, reinforcement learning is the essential driving force behind navigating complex, unpredictable environments. It's the core technology that allows self-driving cars to make split-second, life-saving survival decisions on a chaotic highway. It's also what enables AI systems to utterly defeat human grandmasters in complex games like chess and Go, and it allows highly agile robots to navigate and organize the floors of automated, globe-spanning warehouses. Let's zoom back out. Section 4, Machine Learning in Everyday Life.
So the crucial point is that machine learning isn't just theoretical, and it's certainly not confined to research labs. You interact with it constantly throughout your day. Your phone's face unlock, that uses a highly trained supervised model locked onto your specific features. YouTube and Spotify use unsupervised learning to queue up your next obsession. It's the invisible force optimizing your Amazon shopping cart, silently protecting your checking account from fraud, and analyzing millions of data points to predict traffic flows on Google Maps. Oh, and yes, it is absolutely the fundamental core engine generating those incredibly human-like responses the precise second you hit enter on ChatGPT.
All right, final section, section 5, AI versus machine learning.
Let's move to this next concept and see how this all builds together. Because people often use artificial intelligence and machine learning interchangeably in conversation. But actually, scratch that, they aren't the same thing. Think of artificial intelligence as the grand, overarching concept. It's like a massive, sprawling university dedicated entirely to the broad mission of creating intelligent machines that can simulate human thinking. Machine learning, well, that is simply one highly specialized department inside that university. It's the specific mathematical method of learning from data rather than using fixed programming rules to achieve that broader goal of true AI.
So we've covered a lot of crucial ground today. We've seen how modern computers have completely moved past traditional fixed rules, learning to reliably recognize images, filter out spam, and drive cars by finding patterns and utilizing immense trial and error. But I want to leave you with one final provocative thought. Now that you know how machines learn through these methods, how deep can their learning truly go? As we build incredibly complex, multi-layered neural networks, we're entering a highly advanced, specialized realm called deep learning, which actually attempts to mimic the biological structure of the human brain itself. Wild, right? But hey, that is a fascinating, complex topic for another explainer. Thank you so much for joining me. Keep learning and keep